For regular videos on ancient cultures and forgotten civilizations, please subscribe. Last year at this time, I made 2 videos on the history of the Zodiac. And in the second one, I looked at a proposal made by Dr. Martin Sweatman that animal symbols found on monuments at Gobekli Tepe testify to the existence of the Greek zodiac in prehistoric times. I did not, and still do not, think that Dr. Sweatman made a convincing case. Now, I encouraged Dr. Sweatman to make a video response to my critique, and I'm happy to report he finally has. In fact, I've been waiting for a video response to any of my Myths of Ancient History videos, but so far no one whose work I've critiqued has done so. So, I'm stoked that someone finally has made a rejoinder. I believe that dialogue of this sort, especially in front of a popular audience, is a benefit to that audience. I hope you agree. Let's take a look at Dr. Sweatman's video together, and I'll give you my thoughts. If you want to see his entire video unfiltered, I'll leave a link to it below, but I'm including practically all of it here.
About a year ago, Professor David Miano on his YouTube channel made a highly critical video of my work on the zodiacal theory for interpreting ancient artworks, and especially he focused on Pillar 43 at Gobekli Tepe.
That is indeed true. I don't think my analysis of the history of the Zodiac would be complete without a consideration of his hypothesis, which made quite a stir in online media and continues to be referenced by many of the alternative history crowd as proof of advanced knowledge in the Stone Age.
Now, his channel is aimed at debunking what he considers misconceptions about ancient history. And as my work says some somewhat radical things about ancient prehistory, I suppose my work would eventually fall under his gaze.
As you just heard, Dr. Sweatman acknowledges that he has made some radical claims and is not surprised that I would respond. So clearly there was nothing personal in this. It's just what I do.
Now, David contacted me in advance about this, about making his video, and we exchanged correspondence about the details of my work.
That is true. I wanted to make sure I understood matters fully before commenting, because I didn't want to make a mistake or misrepresent his argument.
I asked David many times instead to write a rebuttal of my research to an academic journal, seeing as my work is published in academic journals. But paraphrasing him, he said this is essentially beneath him and a waste of his time. So he made a video instead.
Dr. Sweatman is misremembering the situation. He never asked me to write a rebuttal in an academic journal instead of doing a video. He did ask me to write my rebuttal in an academic journal, but that was only after my video was published. He wanted me to write a rebuttal in addition to publishing the video. When we had our conversation prior to the publication of the video, he never asked me, even once, to write it in an academic journal. I went back over the logs of our conversation to make sure my memory was correct about this. And it is. Such a request never occurred. In fact, he expressed interest in the forthcoming video and said he was looking forward to seeing it.
Now, the reason I much prefer the usual academic route is that the debate would be refereed by a journal editor, and so any personal digs and criticisms would be prevented. He would have been forced to stick to arguments based on the evidence. Also, it would limit the number of responses, so a never-ending and tiresome back and forth argument would be prevented. David would have his one shot at presenting his key arguments against my proposals. I would have my response, and that would be that.
After my video was posted, Dr. Sweatman responded with a written comment and asked me to pin it to the top for everyone to see. This I was happy to do. You can go there now and see the whole thread with our conversation. When he asked me to write up a paper and have it published so that we could debate it in an academic forum, I told him that since my video was designed for a popular audience, much as his own videos and book are, I encouraged him to respond in video format so that we could open up a public dialogue. He has a YouTube channel. I reminded him that the vast majority of his audience is non-academic, and that he owed it to them to defend his hypothesis in a public forum. Plus, preparing an article for an academic journal takes months. Seeking publication takes more months. And then finally getting it printed takes more months. So, my feeling at the time, and I told him so, was that this was a delay tactic on his part, or a means to take it out of the public eye. The people want to hear about it now. I told him that if he was concerned about fairness, I would be happy to debate him on a neutral platform here on YouTube or on a podcast, but he declined. As for his wish that he could just make one response and that I would not be able to reply to it, well, come on. If you've watched his response video already, which calls into question my character, you would find it reasonable that I should be able to reply to it. And I told him that if he ever did choose to do a video response, I would reply. He decided at that time he would not make a response video. I thought that was that, and I expected never to return to the topic again. Now a year has passed, and he has chosen to respond with a video, so I take that as an indication he is now okay with my replying. Even if he isn't, I have the right to defend myself, as he also does.
Anyway, David published this video instead, in which he targets both my work and me personally, which is unacceptable.
Again, I did not publish the video instead. The video came first, and then the request to put it in an academic journal came afterwards. Also, I did not attack him personally. I do not attack people. I critique their ideas.
My understanding is that his research specializes in the ancient historical period of the Eastern Mediterranean, but not the prehistoric period as far as I understand.
Yes, that's true. And in that sense, we're on equal footing.
But I should add, and I think this is relevant, I don't think David has much, or any, proper training in science or mathematics. And I think this is relevant because my research into prehistory is based on the scientific method, and it uses some basic mathematics. So he's probably not best placed to review it. That's not a personal dig at David at all. I think these are simply the facts.
He says, David may not be qualified to review my work because, it's based on the scientific method and uses basic math. But that's not a personal dig. These are simply the facts. If that isn't a personal dig, I want you to keep that in mind as we go forward and see what he deems a personal dig at himself.
Now, his video criticizes specifically my YouTube videos, which serve as an introduction to my book, Prehistory Decoded, shown here. I never intended these videos to be standalone. They were always intended to serve as a gateway to my book. But my impression from his comments is that David hasn't actually read my book, which is regrettable because I expect it would have helped him to make a better video.
Not only did I read Dr. Sweatman's book prior to the making of my video and use it to fill out my understanding of his videos, I told this to Dr. Sweatman in our discussion under the video. He seems to have forgotten.
Many of his comments are addressed in my book. If he did actually read my book, then that makes his video even worse.
I wish I knew what comments of mine are addressed in his book, but sadly I couldn't find any instances in this video where he provides an example, so it's impossible for us to assess the truthfulness of this statement.
Now, I'm not going to try to rebut every sentence in David's video. That would take far too long. His video is nearly an hour and a half long, and it would take me 5 times that to address every point, at least.
I think that's fair, as long as he rebuts the parts of my critique that are aimed directly at his thesis.
So, instead I'm just going to focus on those parts where he attacks me personally, and on the part where he tries to use my statistical method for evaluating Pillar 43 at Gobekli Tepe, which is the most important part of this whole debate.
I'm surprised to hear him say that this statistical test, which he refers to as his subjective test, is the most important part of this whole debate. He says quite clearly in his videos that it is his other test, the one he calls his objective test, that demonstrates with certainty that his hypothesis is correct. How did his subjective test suddenly become the most important part?
So let's jump forward to his first criticism.
I'm Martin Sweatman. I'm a scientist at the University of Edinburgh, and in this series of videos I'm going to show you how we discovered a very ancient zodiac.
You may be curious what kind of scientist Martin Sweatman is. He's a chemical engineer with a PhD in physics. That expertise doesn't really come into play in this hypothesis, but he does put his general knowledge of scientific principles to use, not so much in the formulation of his hypothesis, but in the defense of it. Dr. Sweatman refers to this as my first criticism, but this is just part of my introduction, the part where I provide some background info on the person whose ideas I'm considering. This is merely to let people know who Martin Sweatman is and why he might be important and why they might want to watch this video. I didn't even get to my criticisms yet.
Well, I would strongly disagree with David's assertion there. My expertise is in statistical mechanics, which means my professional research concerns the analysis of the configurations of atoms and molecules. And this is exactly the kind of expertise that is useful in decoding the symbols at Gobekli Tepe. The logic and maths that are used to analyse configurations of atoms and molecules can be applied straightforwardly to patterns on stone pillars. There's really not much difference. Of course, David wouldn't know about that because he's got really no idea what my professional research is all about.
Statistical mechanics does employ statistical methods to the study of microscopic entities. And as I said, I do think the general principles he learned in his field prove useful, but the narrower focus of statistical mechanics may create some blind spots and pitfalls which an expert in statistics would be less likely to fall prey to. The fact that his tests are riddled with errors is testimony to this. And remember, I said that his scientific expertise doesn't come into play in the formulation of his hypothesis, but only in the defense of it, that is, the testing of it. Some knowledge of statistics would serve him well in the testing of his hypothesis. But my point still stands. The formulation of his hypothesis did not employ statistics or any other science. He just came up with ideas. Maybe you could say that to come up with a hypothesis that could be tested by statistics, you have to know statistics. In that case, yes, I can acknowledge that his training would come into play for that. I just meant when he thought to himself, maybe these are constellations, and maybe that's the sun, and these are equinoxes and solstices, all that this was not done scientifically. And please keep in mind that the statement I made is not part of my critique. I wasn't saying that his thesis is invalid because of his education or training. Those of you who have been following me for a while know that I have repeatedly said, both in videos and in comments, that I judge claims by their merits and not by who says them. Dr. Sweatman, however, as we shall see, does not appear to hold this view.
So I would contend that my expertise is far more useful than David's, and for the same reason, more useful than Gobekli Tepe's archaeologists.
This sounds very gatekeepy to me. Does it to you? It gives the impression that Dr. Sweatman is saying that because he is an expert in statistical mechanics and I'm not, then it's not my place to call his conclusions into question. It sounds like one of those academics who says, "Hey, stay in your lane, buddy. I'm the authority here." To be clear, I value expertise. I'm one of those who believes that in an area in which I am not an expert, I should defer to the experts. But that means the consensus of the experts, not the opinions of a single expert.
Actually, I think David's comments there reveal a deep-seated bias against science and what it can offer.
This statement I had to mull about for quite a while. I'm trying to figure out how Dr. Sweatman could have thought my comment revealed a bias against science. I'm guessing because he imagined I was thinking in my mind that only archaeologists' views should be valued? But that's not my meaning at all. I just meant that although he tested his hypothesis scientifically, he didn't arrive at his hypothesis scientifically. In other words, it wasn't a step-by-step process using evidence to arrive at each step.
He's even warned me directly on Twitter to stick to my own research field, which is a kind of genetic fallacy. In other words, he thinks only people like him, so historians and archaeologists, can know the truth about our past. But that kind of thinking is philosophically bankrupt and eventually leads to the creation of religions with people like David as their priests.
This is some red meat for the fans, I guess. Those historians and archaeologists are trying to tell us what to think. I find this ironic, though, because numerous times Dr. Sweatman has appealed to his standing as a scientist to argue that he can know the truth about our past better than archaeologists. I don't remember telling him to stick to his own research field. It doesn't sound like something I'd say, but I can't check it to confirm because he has me blocked for some reason.
I think this shows he doesn't really understand the scientific method at all. And this is amply demonstrated in his video. For example, he makes frequent errors in his video that relate to his misunderstanding of the difference between developing a hypothesis and testing a hypothesis. He confuses these time and time again. It gets very tiresome. For example, he criticizes the parts where I'm simply developing a hypothesis by effectively saying, "But you don't know that," or by asking for strong evidence to justify an assumption, which is anti-science.
This is not true. It may just be that he misunderstood me, and I put that on myself for not being clear enough. In my video, the parts of his hypothesis that I criticize for not being backed with evidence generally are the parts that he does not test.
Science begins with a guess. No justification for the guess is needed, because that would then result in a never-ending cycle of justifications. Then, once you have guessed a hypothesis, you test it by comparing predictions with observations. And that's it.
I'm fully aware of that. The problem I have with Dr. Sweatman's tests is that they are partial tests, but he presents them as if they test all of his claims, which they do not.
Well, whatever David thinks about it, I think it remains the case that my hypothesis is the only one for which a statistical test has been created.
I assume he means the only one of the ones made about Gobekli Tepe. But what would that prove?
It's not perfect yet, but I clearly point out the areas that are subjective and which might become more scientific in the future with more work on the pattern matching algorithm. That's something I'm currently working on.
It does have some serious flaws. For some reason, anyone who points them out is stepping out of line. It turns out that Dr. Sweatman is a big fan of alternative history and lost high technology.
Now that's a slanderous fabrication. I have never uttered fanatical or even mild support for the idea of lost high technology. This is completely unacceptable, and David should remove his video or remove that remark from his video.
Let me explain how I came to the conclusion that he was a fan of lost high technology, so you can understand why I said this. When people hear the phrase, sometimes ancient aliens comes to mind, but there's a spectrum of beliefs about lost high technology. The basic idea is that there was, in the Stone Age, prior to a great catastrophe, a group or groups of people who possessed technology higher than what is indicated in the archaeological record, or what is generally believed by archaeologists and historians, and that this technology was lost in the catastrophe and had to restart. Dr. Sweatman's thesis proposes that Stone Age culture most certainly had an astronomical science more advanced than what is generally assumed, which included a knowledge of axial precession. He says this explicitly, the wobble of the Earth on its axis. Now, it seems to me that this knowledge is not possible without knowing the Earth is spherical, and without knowing how to pass recorded information down over long periods of time. This is a science higher than what is generally assumed for this period. The rate of precession corresponds to a period of 25,772 years, so in order for humans to have figured it out, they would need to have records spanning thousands of years, which were preserved and handed down from generation to generation without alteration. In his words, quote, "The concepts represented in the pillar require communication over very long time scales," unquote. Indeed, the symbols at Gobekli Tepe, he asserts, are a form of writing. This is a technology more advanced, yes, higher than what is assumed for this period of time. In his book, Prehistory Decoded, Dr. Sweatman also posits that the Egyptian myths of Zep Tepe may indeed refer to, and I quote, "a golden age of civilization in Egypt that has since vanished or been destroyed by a cataclysm, and that the Sphinx is a product of this lost golden age civilization." Going by the controversial dating of the Sphinx suggested by Robert Schoch and putting it thousands of years earlier, it would require an assumption that the people in that area during the Stone Age had a higher technology than what the archaeological record indicates for that period, especially if you imagine a golden age of civilization at that time. So now I hope you and he can understand why I said this. It's a perfectly reasonable conclusion. I should add that in one of his videos that I responded to, he makes this statement.
So remember that many aspects of modern earth science have traditionally been built on the edifice of gradualism, which rules out cosmic impacts from the very beginning. And now we now know this is very clearly wrong, even on the timescale of human development, on the timescale of Homo sapiens. So we now know that we need to take account of catastrophic impacts with cometary debris, which often don't even leave craters. So this could be important for our understanding of the ancient climate, ancient animals, and ancient plants, and their extinctions, and so on. And it even affects our understanding of evolution. So we need to make sure that this version of catastrophism is taken into account in how we think about evolutionary biology.
What is this clash between gradualism and catastrophism that he's talking about? When people use the term gradualism, they mean development or progress by degrees. It applies not only to earth sciences, but to technology. Catastrophism challenges the assumption that technology develops and progresses gradually over time. It assumes that technology can be set back by a catastrophe and will need to restart again, so it's not a single line of development. We have to conclude that as an opponent of gradualism and a proponent of catastrophism, Dr. Sweatman assumes a setback of technology due to the Younger Dryas comet impact. This necessitates the view that there was lost advanced technology. He may not envision it to be as advanced as some others might, but catastrophism assumes lost technology that was higher than what came after. And this interest preceded his work on the subject, so it would seem his efforts were intended from the beginning to establish the truth of lost advanced civilization.
Again, this is completely untrue, another slanderous fabrication. I have never uttered support for any lost ancient high civilization. If you had read my book, David, you would know this. Again, you need to remove your video or this slanderous remark from your video.
Dr. Sweatman is not giving you the context of my statement he just played. I said it in response to a comment that he made that an interpretation of Pillar 43 by Graham Hancock was the impetus for his research on this subject.
I've been following developments at Gobekli Tepe since it was made public in about 2005, but I was none the wiser until I read Graham Hancock's book Magicians of the Gods.
This book advances the idea of, you guessed it, a lost advanced civilization. This is what I was responding to. I truly wonder why Dr. Sweatman, who says he's not a fan of such ideas, would take interest in this book and form a hypothesis based on a suggestion made by this book. If he doesn't want to be associated with Mr. Hancock's views, why would he name drop him and say that the book made him wiser? Why would he appear at Hugh Newman's Megalithomania conferences? Why would he write for Graham Hancock's website? I'm not trying to suggest that Dr. Sweatman holds the same views as Newman or Hancock. What I'm wondering is why he's so offended that I associated him with lost high technology so much that he considers it slanderous and defamatory, and at the same time rub shoulders with lost high technology proponents and not be embarrassed by it. Why is he telling me to delete my video but not asking Graham Hancock to take down this photo?
Of course, it suits David's purpose to misrepresent me personally like this, which is why I would rather he had written a journal paper, because these kinds of personal attacks would not be allowed in a journal paper. So no, I have never uttered support for a lost ancient high civilization or for lost ancient high technology.
You can rest assured that if I ever did write a paper about it, I most certainly would bring up where he got his idea from and his comments about the Sphinx in a golden age of civilization.
What I do think, based on the available evidence, is that ancient people were keen, naked-eye astronomers. Nothing to do with ancient high technology or ancient high civilization, just good, naked-eye astronomy. But this should be expected. There is every reason to expect ancient people would be good astronomers, given that all resources at that time, tens of thousands of years ago, depended utterly on the seasons. People lived at that time completely in tune with the seasons. They had to survive. And the seasons can be tracked accurately with simple naked-eye astronomy through the solstices and equinoxes.
Naked-eye observation without knowledge of precession is reasonable to me. As I said in my video, I'm open to the idea that some of the symbols at Gobekli Tepe could be constellations. It also is reasonable to suppose people were familiar with the seasons and the changes in the sky, though it will become way more important later when agriculture depends on it. You don't have to have telescopes to have more advanced tech than what most people think Stone Age cultures had. By the way, if the sun were this high in the sky, how would anyone see any stars? If this were a visual observation, wouldn't the sun be absent? At night or just before sunrise, the sun wouldn't be there.
I'm far from the first person, academic or otherwise, to suggest this, and there is plenty of evidence to back this up. And if David had read my book, he'd know this was my view.
I did read his book, and I knew that was his view.
Now, the surprising thing my work does suggest is that ancient people, like those at Gobekli Tepe, were using some constellations that are similar to our modern ones. Not exactly the same, but sufficiently similar that we can see the correlations.
Yeah, I didn't see many correlations. Only the scorpions stood out as being similar, none of the rest.
Of course, David misrepresents my position on this too. This is one of his favourite strategies. It's called the straw man fallacy. So what he does, over and over again in his video, is misrepresent my ideas, and then he proceeds to criticise those ideas. He makes sure the misrepresentation is close enough to fool the unwary, but nevertheless, his criticism applies to the things he has made up and not my ideas. It's classic straw man tactics.
I don't think I strawmanned him. I certainly didn't intentionally. Let's see what examples he gives and see if I did.
See what he says here, for example.
For our purposes, we're focusing specifically on whether the Zodiac, that is, the Zodiac whose origins we were able to trace firmly only to about 500 BCE in Babylonia, existed here, thousands of years earlier. Actually, not specifically the Zodiac, but the entire Greek set of 48 constellations, which we established last time to have been subsequent to the Babylonian system.
That's completely untrue. I have never made that claim, nor do I have any evidence for it. I claim only that some of our familiar zodiacal and a few nearby constellations were known approximately, nothing more. What I mean by approximately is that they were sufficiently similar to be recognizable in terms of the symbols used. So that's just one example of his favorite strategy, the straw man fallacy.
Ah, I see. So he says that he's only claiming that the Zodiac and some of the other Greek constellations existed in approximate form, thousands of years earlier. Whereas I said he assumed the existence of the Zodiac and all the other Greek constellations. But please note that I did not state that he claimed this. I stated that my video will be focusing on the question of whether both the Zodiac and the rest of the Greek constellations existed back then. The reason I said we have to focus on that is because he is open to the idea that any of the Greek constellations could have existed then. He doesn't find evidence for all of them, but he is open to the idea. All of them are on the table, so we have to discuss that as a topic. I do, however, acknowledge that someone not paying strict attention to my wording could mistakenly assume I was attributing something to him that he never claimed. So I apologize for my lack of clarity there.
Let's look at another example of this kind of fallacy, which in my view is the only one that really matters in David's entire video. This is the part where he attempts to use my statistical method to evaluate Pillar 43.
This is the only one of my fallacies that really matters? Okay. I guess he could have started here.
Just so that you know what's going on, to provide some context, in this part of my statistical analysis of Pillar 43, I compare each animal symbol that appears at Gobekli Tepe with the constellation that we hypothesize is represented by an animal symbol on Pillar 43. So take Pisces, for example. We hypothesize that this bending bird at the top left of Pillar 43 represents the constellation Pisces, which would be the autumn equinox constellation at the time of the Younger Dryas impact, roughly 10,800 BCE. So here they are shown side by side. Now this is my hypothesis. In this case, it's that the bending bird represents Pisces. To test this hypothesis, we compare all the other animal symbols at Gobekli Tepe with the same constellation, Pisces in this case, and put them in ranked order. And we do that for each of the animal symbols on Pillar 43. So here is the table of the 7 constellations we expect are written on Pillar 43, in addition to Scorpius the Scorpion, with the animal symbols ranked against them. And as you can see, according to my view, in nearly every case, the animal symbol already in that position on Pillar 43 is better, or as good as, any other animal symbol at Gobekli Tepe for representing that hypothesized constellation. So, for example, I rank the bending bird first amongst all the animal symbols at Gobekli Tepe for representing Pisces, and so on.
He says in this test we are to compare all the other animal symbols at Gobekli Tepe with the same constellation. I want everybody to note that he gives you only 11, but there are far more animal symbols found at Gobekli Tepe than just 11. And there may indeed be more found there still, as well as in the other tepes in the neighborhood. So the question to ask ourselves is, how useful is a test such as this if it doesn't include all the animal symbols? You need an accurate number of permutations, right? By keeping that number as low as possible, just 11, he rigs the test so that anyone taking the test is more limited in options. That means they are more likely to find fewer possible similarities between animals and the constellations.
So according to my view, represented by these rankings, it's extremely unlikely that the best animal symbol would appear in every position on Pillar 43 rather than some other animal symbol that could have been chosen if they were placed purely by chance.
Please take note, because what he says here is very important. He's testing what the odds are his interpretation is correct over whether the symbols were placed by pure chance. He came out to 1 in 20 million. Now correct me if I'm wrong, but it seems to me that a test that calculates whether placement of symbols is random or not, as this one does not establish that another non-random system wasn't employed here. If, for example, someone had another theory, which proposes that the symbols are placed and oriented on the pillar exactly as they would expect them to be, they too would come out with statistically significant odds, would they not? And I would say the same about their hypothesis. It is 1 in millions more likely to be correct than to be random, but that doesn't mean their interpretation is the most probable of all non-random interpretations.
And what this means is that Pillar 43 can be read as a kind of date stamp, since the constellations we hypothesize are represented on it can be read as a date using precession of the equinoxes. So that's the essence of this hypothesis test.
If what we see on the pillar could be established as the representation of the sky at a given point in time, he thinks it was on the summer solstice, it could be understood as giving a date, only if we understood a date to mean a time period hundreds of years long. This is because the configuration of the constellations would look like this on the summer solstice for centuries, not usually what we think of as a date. Also, making a drawing of what is seen in the sky in itself in no way indicates knowledge of precession of the equinoxes. And it needs to be pointed out that his test, which he uses to claim that his entire hypothesis is correct, doesn't. For example, it doesn't test the likelihood that the depiction of the sky on the pillar represents what it looked like on the summer solstice, a key part of his thesis. He calculated the probability that the symbols around Scorpius would be in these positions, but he never calculated the probability of whether this image represents what was seen on that day of the year. This configuration could fit many different times.
Note that I'm comparing the constellations as they appear in Stellarium, which is a popular astronomical software, with the animal symbols at Gobekli Tepe. And by constellations I mean the patterns of points and lines in Stellarium, shown here.
One of the things I had a really hard time understanding, and still do, is why Dr. Sweatman made a test that matched animal symbols to constellations, but didn't include a test that matched constellations to animal symbols. That way he could determine the odds that an individual animal could be connected to a constellation. Is he not interested in knowing this?
Now, of course, you might disagree somewhat with my rankings, but nevertheless, by going through this same exercise, you can obtain your own statistic for how good the hypothesis is. You can come to your own conclusion.
This is where we get to another problem with this test. It commits what is commonly called the Prosecutor's fallacy. This is a fallacy in statistical reasoning that often occurs when evidence is compared against a large database. The size of the database increases the likelihood that a match will be found. In this case, the database he is using is the configuration of stars seen in the sky from Gobekli Tepe over a period of thousands of years. He claims a very low probability that the configuration on the pillar would match a specific date he posits. But the fact is, this pillar matches the configuration of the sky on many dates, not just one. He commits this fallacy by assuming that the prior probability of a random match is equal to the probability that his hypothesis is correct.
So what does David do with this hypothesis test? After all, this is the absolute key to my theory. Well, as I said, he performs another straw man fallacy. You see, what he does, or at least what he says he does, is ignore the lines in the stellarium, and then he somehow compares the distribution of constellation points, so that's the positions on the stars only, with the animal patterns. Let's see him do this.
Okay, I've put in my ranks. Very subjective, of course, as anyone's would be. Many of Dr. Sweatman's choices, I don't agree, match the constellations to the best animal, as you can see. And to be clear, I use the configuration of stars, not the lines. Okay, the drawn lines there are modern. Let me ask you something. If someone devises a test to test a hypothesis and asks you to take it, and the test is flawed, do you take the flawed test, or do you correct the test and then take it? In this case, it seemed best to me to correct the test. As it stood, even though he was making claims that these were ancient constellations, the test was using modern ones. So, I made an adjustment accordingly. What I also should have done was include all the animal symbols of Gobekli Tepe in the test. This would have strengthened the accuracy of the test considerably. But Dr. Sweatman is miffed that I didn't take the test as he rigged it.
But that process is nonsense. It's meaningless to compare points without lines between them with a two-dimensional animal symbol. You see, points are dimensionless, so they can't map out any two-dimensional pattern at all, unless you connect them up somehow, for example, with straight lines. That's just basic mathematical logic. Of course, David doesn't realize this, probably because he's almost no training in mathematics.
Look, I understand that the test doesn't work as well that way, but you don't sacrifice the accuracy of a test just so that you can take more subjectivity out of it.
In effect, though, although he doesn't say this explicitly, he is implicitly making up his own lines and patterns in his imagination.
Yes, constellations are an exercise in pareidolia.
Now, as I said, David and I had communicated via direct message on Twitter about this, so he knows very well my argument. But instead he decided to effectively make up his own constellations. He never actually reveals the lines he was imagining between the points. He just asks you to trust that he has made up some good ones, and then he compares them against the animal symbols.
I didn't make up my own constellations. They're the same group of stars. Think about this for a minute. The lines of the constellations, whether modern or ancient Greek, are based on the outline of an animal or person. But apart from the scorpion, Dr. Sweatman has opened up the possibility that different animals were used at Gobekli Tepe than in Greece, or now. That changes the lines. The lines outline a shape. If you connect the dots to create a shape, to create a different shape, you would connect dots differently. How can you say that the lines that represent the shape of two humans can now be used to represent the shape of a gazelle? You get what I'm saying?
Now it's obvious to anyone that this is not my hypothesis anymore. He's implicitly made up his own lines, so he's testing his own hypothesis, not mine. That's the straw man argument right there.
He has the freedom to make whatever hypothesis he likes, but he doesn't have the freedom to make whatever statistical test that he likes. The test is only valid if it tests his hypothesis accurately. If it tests something else entirely, or if it tests only a portion of his hypothesis, or it tests his hypothesis inaccurately, it can't be used to validate his hypothesis.
In fact, it's worse than that, because by making up his own patterns, which he never actually reveals, he creates an invalid hypothesis. You see, in order for a hypothesis like this to be valid, it's not allowed to depend on anything which might be influenced by the person making the hypothesis. So, in my case, I'm comparing the animal symbols at Gobekli Tepe with the constellations, that's the lines and points in Stellarium, and I've had no influence on either of them. They both existed before my hypothesis was developed. But in David's case, he implicitly made up his own lines, which means they could easily be biased. And that invalidates his hypothesis. If I had made up my own lines to fit the animal symbols on pillar 43, that would be equally invalid. And David would have pointed that out as a flaw straight away, with good reason.
Yes, and this is my point. His own test, despite his denial of this, is influenced by him. He influenced it in several ways. He limited the number of animals in the test, which affects the outcome in his favor. He created the test with the presumption that the constellations of Libra and Ophiuchus are oriented properly on the pillar, when they are not. These factors corrupt his test. He also allowed for the constellations to be rotated in any direction, which affects the outcome in his favor. In other words, the animal does not have to match the constellation in the sky as it is seen. It can be sideways or upside down. Now, I know he will say, well, that is my hypothesis. My hypothesis says the people recorded what they saw in the sky without regard for the rotational orientation of the constellation. Think about how nonsensical that is. Can you imagine this conversation? Hey, Joe, make sure that when you carve the figures on that pillar, each one matches the shape of the constellation. Very important. Oh, and also, they have to be placed in their correct positions in the sky, too. Don't mess up on that. Can I put some of them upside down? Yeah, sure, no problem. Right? But that aside, by allowing the symbol to be in any rotational position, he decreases the falsifiability of his claims, thereby compromising the usefulness of his test.
In fact, David asked me specifically about this point. He asked me what this line in our paper meant. So this, what I'm showing here, is our rebuttal of the archaeologist's response to our initial Fox paper in 2017. So here we say, note that we are comparing given constellations with given animal symbols. This is not an arbitrary process and is therefore statistically meaningful. What this means is that our hypothesis is valid because we have no influence on either the animal patterns on pillar 43 or the constellation patterns in Stellarium.
I repeat, he did influence the test.
On the other hand, just underneath, we say, it is common in popular media and across the internet to take a different approach, where given or arbitrary symbols are compared with arbitrary star patterns. This strategy is statistically meaningless and therefore not scientific. This means you're not allowed to make up your own star patterns. Now, even though I explained these sentences to David at length, he seems to have ignored them.
The reason I made this video in the first place was to see if ancient Greek constellations were represented on this pillar. If the test uses modern configurations of constellations, then it leaves the question of ancient Greek constellations out of it.
Now, David's argument for making up his own lines, as you just heard, is that the lines in Stellarium are modern, and therefore they aren't valid either. Let's hear him say this again.
To be clear, I use the configuration of stars, not the lines. Okay? The drawn lines there are modern.
So according to David, it doesn't matter that he effectively made up his own lines, because the ones in Stellarium are modern inventions too, and he doesn't see any difference. Of course, this argument is nonsense. It assumes that David's implicit or effective lines, which as far as we know are completely random, are as good as the lines that appear in Stellarium, which is of course ridiculous. And here's why. For starters, we can assume the makers of Stellarium are trying their best to reproduce the Greek constellations, by which I mean the points and lines.
The makers of Stellarium are trying their best to reproduce the Greek constellations? Unless he knows something that I don't know, the constellations in Stellarium are not meant to represent ancient constellations. They are meant to represent our own constellations that we use today. Now, I realize that some of our modern constellations can be traced back to ancient Greece, but they also include any and all revisions since.
And secondly, the Greeks wrote down their constellations with the intention that they could be reconstructed in the future. The best source we have is from Ptolemy's Almagest, about 150 AD, where he describes the position of each star in a constellation in relation to its symbol. So here's the page in Ptolemy's Almagest relating to Pisces. As you can see, these descriptions are very detailed and should allow construction of the constellation lines by themselves. Just in case there is some doubt, we also have the Farnese Atlas, which actually tells us what the symbols looked like. And again, this is from about 150 AD, and it's thought the Farnese Atlas and Ptolemy's Almagest are both based on the constellations of Hipparchus from about 150 BC. So from these sources we can recreate the Greek constellations, that's the points and lines, as the Greeks might have imagined them, at least approximately.
Okay, now this is great. This is something he should have done before. It's a necessary component of his argument. If you're going to argue that the constellations at Gobekli Tepe are approximations of ancient Greek constellations, use the ancient Greek constellations.
Can we recreate them perfectly? No. But we can expect that the points and lines in Stellarium are a reasonable reconstruction of how the Greeks saw the sky, because the Greeks told us what their constellations looked like, and the makers of Stellarium are deliberately trying to reconstruct them, using points and lines as best they can.
No, this is in direct contradiction to what Stellarium itself states.
At the same time, we can have no confidence in David's imagined lines, because they're biased, as he made them up himself, and he doesn't reveal them anyway. So his hypothesis is fundamentally flawed, and this should be obvious. In fact, it's so obvious that it calls into question David's competence in this area. He seems to have a very limited understanding of the scientific method, and as I said at the beginning, David has limited experience with scientific hypothesis testing and mathematics, and I think it shows. I think he's out of his depth here.
You know what would be a great statistical test? Add up all the ad hominems in Dr. Sweatman's video, and add up all those in mine, and compare.
Indeed, I think it's fair to ask why David did this. It's so obviously flawed, there must have been a strong motivation for him to do this, rather than use the lines in Stellarium or similar software. My guess is that David realized that if he did use the lines in Stellarium, as they are, rather than making up his own, he would get a strong statistic that he felt he would have trouble arguing against.
Dr. Sweatman apparently is none too pleased that I wouldn't take the Kobayashi Maru as he programmed it.
And there's a clue in his video which supports this view. Let's listen to what he thinks of having to use the lines in Stellarium.
If you or I wanted to do this for our own matches, and have him judge ours, we would get to place ones in all the boxes, and it would come out to a probability of 1 in 140 million. Now let's say that you thought none of the animal symbols fit. What would you put in the box? Not an option. He's forcing you to choose a number.
Yes, I'm forcing you to use my hypothesis, David. That's the whole point. And by the way, it's not about matching, it's about ranking. What David is saying, though, is that he doesn't like to be forced to use the lines in Stellarium. But if you don't do that, David, it's no longer my hypothesis. He's basically admitting defeat here.
I'm not testing my hypothesis. I don't have a hypothesis. The problem is that his test doesn't properly test his own hypothesis.
What this shows, I think, is that David is having trouble reconciling what he thinks he knows about prehistory with what his own eyes are actually showing him. And he simply can't face that level of cognitive dissonance.
Okay, he's just flexing and posturing now.
In any case, his entire YouTube channel is dedicated to debunking what he sees as misconceptions about the past, not agreeing with them. So he's got a huge amount of skin in the game. There's no way he was ever going to agree with me. The problem for David is that sooner or later he's going to tackle an issue that is actually correct and isn't a misconception at all, and he's going to look a bit foolish.
Just to be clear, my entire channel is not dedicated to debunking misconceptions, only this series. And it is not dedicated to debunking what I believe to be misconceptions. It's dedicated to debunking what archaeologists, historians, and scientists as a whole consider to be misconceptions. If you, for 1 second, think that the scientific consensus on Gobekli Tepe agrees with what Dr. Sweatman is saying, you would be mistaken. Mind you, they haven't all weighed in on it, but there isn't a single independent published paper that I've been able to find that corroborates or replicates his findings. This is bad science, and I'm willing to stake my reputation on that.
Anyway, I think it's obvious that rather than confronting my hypothesis properly, he ducked it entirely by making up his own lines and his own hypothesis. Classic strawman fallacy.
I didn't make his test appear weaker than it is. I attempted to make it stronger.
And it doesn't get any better. David uses several other kinds of fallacy, apart from the many strawman fallacies, in his video. For example, David sometimes states things as fact, when in fact they are not known with any certainty. This is strange behaviour for a historian who should know better.
Is it a fallacy when someone states something as fact when it isn't? I think that's just being wrong. Was I wrong? Maybe. Let's find out.
Let's take a look at an example.
We learned in our last video that the ram symbol for Aries was certainly not the original one in Babylon. I suppose we could assume that the ram tradition can be traced back to another source, but the problem is we already know that the classical set of constellations combined two separate traditions, and that could have happened no earlier than the Hellenistic period. Yet Dr. Sweatman wants to assume the combined system existed thousands of years before it possibly could have. It's all very ahistorical and anachronistic. He needs to address this objection, and as far as I know, he never has. And I don't mean just saying, oh, well, the mainstream view is wrong. I mean, show us how your system doesn't contradict any of the existing evidence.
So, David thinks it's known beyond any doubt that the Greek set of constellations were created in Greece in the latter part of the first millennium BC, shortly before Hipparchus. In fact, this is not known with any certainty. It's just a convenient story that historians like David like to promulgate based on a logical fallacy.
The evidence for this is given in my first Zodiac video. You can go check it out and judge for yourself. But here are the cliff notes. Ancient Greek writers testified to the fact that the Greeks borrowed the zodiac from the Babylonians in the 4th century BCE. So the full set of Greek constellations could have been completed only after that happened.
What we do know is that the first written evidence we have for our zodiacal constellations dates back to the Mulapin and the 3 stars each lists, which at the earliest date to the mid-2nd millennium BC in Babylon.
All of the constellations of the Babylonian zodiac do appear in the Mulapin, though not as a set of 12. The 3 stars each lists, which are earlier, do not contain all the constellations of the zodiac, only some. But remember, we're in Babylon, and in Babylon, many of the other Greek constellations, the non-zodiacal ones, are not here. They clearly at this point have not yet been combined. They're still separate. That is why finding them together at Gobekli Tepe is anachronistic.
And we also know that the first written evidence we have for any of our non-zodiacal constellations is in the early classical Greek texts, such as Homer's Odyssey, which were probably first written down significantly before 700 BC. And that's it. We don't know when any of these constellations were actually invented.
He's right, we don't. But what we do know is that these constellations were invented at different times and different places in history, and were only brought together by the Greeks in the Hellenistic period.
And we certainly don't know when the full set of Greek constellations we know today was assembled. It's entirely possible that the full set of constellations was already assembled, say by 3000 BC, and that, for whatever reason, the Babylonians decided in the mid-2nd millennium BC to write down some of the zodiacal constellations, and that a few hundred years later, the early Greek authors decided to use some non-zodiacal ones in their stories. And that view is entirely consistent with the historical evidence we have.
The assumption that both of these societies had the full set is not only unsupported by the evidence, it is contradicted by the evidence.
And you don't need to take my word for it. That's basically the conclusion of this paper by Professor Bradley Schaefer, which is probably the best paper published on this subject, published in the Journal for the History of Astronomy, where he suggests that based on all the available evidence, the full set of Greek constellations was likely known already by 1100 BC and possibly earlier.
I want to thank Dr. Sweatman for pointing to this paper, an excellent study, by the way, which concludes convincingly that the astronomical lore in the writings of the Greek Eudoxus, who lived in the 4th century BCE, is based on observations that were taken in 1100 BCE in Assyria. That's northern Mesopotamia. Dr. Sweatman mistakenly concludes that this means the Greeks had all this astronomical lore in 1100 BCE. But that is not what Dr. Schaefer concluded. He wrote another article shortly thereafter titled The Origin of the Greek Constellations to give the bigger picture, and I'm excited to share this information with you. His findings comport with everything I have said. Dr. Schaefer does not say that the Greeks had their full set of constellations by 1100 BCE. He says that the Mesopotamians had their full set, or at least most of them, by 1100 BCE. These are the constellations listed in the Mulapin. In my video, I stated that the observations of the Mulapin probably dated back to 1000 BCE. Dr. Schaefer has been able to pinpoint it more precisely to 1100 by looking at the relative positions of the constellations in the Mulapin and comparing them to how the night sky appeared in certain places at certain times. This is fantastic information. But the Greeks, he says, did not obtain this lore until later. Please note how Dr. Schaefer describes the Greek constellations before they met the Babylonians. The two earliest written sources from the Greeks, the Epics of Homer, assumed to be 8th century BC, and the Farmer's Almanac of Hesiod, also dated to the 8th century, both mention two prominent constellations, Orion and the Great Bear, two star clusters, the Pleiades and the Hyades, and two stars, Sirius and Arcturus, but nothing more. And all other Greek sources from before about 500 BC are silent on the stars. So the Greeks had the most prominent star pictures before 500 BC, but perhaps not many more. His examination of the work of the Greek writer Eudoxus, who lived in the 4th century BCE, and who presented the system of constellations at that time, crediting the Babylonians for much of it, revealed that it basically was the same as in the Mulapin. I have noticed that Mulapin and Eudoxus share a substantial amount of information, leading me to conclude that the data used by both came from an original database made by an Assyrian observer around 1100 BC. Because both surviving branches contain most of the ancient constellations, albeit some with different names, I conclude that the set of constellations was largely complete by sometime around 1100 BC. Therefore, it is reasonable to conclude that sometime after this, and before the existence of Eudoxus's book, 366 BC, the Greeks received the Mesopotamian star groups. You see that? Between 1100 and 366. The lack of any evidence for the Greek constellations, other than the Bear and Orion mentioned in Homer, before 500 BC, suggests that most of the transfer happened after that time. So he's saying probably between 500 and 366. We know from textual evidence that the Babylonian Zodiac system came to Greece around 400 BC. This is perfectly in line with what I've been saying all along, and is at odds with what Dr. Sweatman is arguing. Dr. Schaefer also notes that the Greeks brought other constellations into their system that were not of Mesopotamian origin. Despite the heavy reliance on Mesopotamian star groups, the Greek system of constellations still has 18 star pictures with no roots in the east, nor anywhere else that we can discover. Moreover, the nature of these constellations is characteristically Greek. There is the quintessential Greek hero Hercules, for example, joined in the sky by other constellations that represent creatures the great warrior had defeated, Leo and Draco among them. Ophiuchus, carrying the serpent, is there as well, and the dolphin, as would be appropriate for a seafaring people such as the Greeks. 6 of these constellations depict a tableau from Greek mythology concerning Perseus's rescue of Andromeda. Most likely, these new star pictures were invented by the Greeks themselves. I thank Dr. Sweatman for citing this article, as it further reinforces the view that constellations like Ophiuchus had a separate origin from the Babylonian set of constellations.
Schaefer's conclusion, by the way, is based on the evidence contained in those written texts, on what they actually say, and is not just based on when those texts were written. David, on the other hand, is, I think, basing his view only on when a few surviving texts were written. His view doesn't take into account the possibility that not everything that happened in history was written down, and that not everything that was written down has survived. His view is a kind of perfect, idealistic view of the surviving, written historical record, and it also ignores other forms of evidence. And it's basically total nonsense. Indeed, there's a convenient phrase for this kind of logical fallacy, which is that absence of evidence is not evidence of absence.
If Dr. Sweatman had paid better attention to my video, he would have realized I didn't date the constellations to the time of their earliest recording.
In any case, this entire point is another straw man fallacy. Remember, I have never suggested that the entire set of Greek constellations existed at Gobekli Tepe, so any discussion about exactly when the Greek constellations was assembled is irrelevant. David is making a straw man fallacy on top of a logical fallacy.
No, but he did make the claim that constellations from two different systems were together at Gobekli Tepe before they had actually been brought together. He is thousands of years off on this.
In fact, when you remove all the personal attacks on me and the numerous straw man fallacies, and all the logical fallacies, and all the genetic fallacies, and all the demonstrably incorrect statements, and all of his archaeoastronomical errors, and all of his misunderstandings about the Younger Dryas comet impact, and all his misunderstandings of the scientific method, and all his misunderstandings of mathematics, and his idealistic view of the historical record, you'll find there's almost nothing left of his video. No wonder he wanted to make a YouTube video rather than write a proper journal paper.
This is like saying, there's a bunch of other stuff I could say that would totally demolish him, trust me, but I'm not going to bother pointing them out right now. So, those are my thoughts on Dr. Sweatman's rejoinder video. I hope it clarifies a few things. Let me know your thoughts in the comments below. If you got something out of this video, please give it a thumbs up. If you'd like to help out the channel further, you can become a patron for as little as $2 per month at patreon.com/World of Antiquity. You might like my little e-booklet, Why Ancient History Matters. It's designed to persuade people that the subject is important, even in the modern world. You might also wish to use it to help spread the word, so feel free to share it with someone you know. It's free for anyone who wants it. I've left a link in the description box below the video for you to grab a copy. Catch you later.